Welcome to another session of Ebenezer GATE coaching classes. This is a problem that appeared in GATE 2026. It is a multiple select question for 2 marks. That means more than one answer is correct. Let x1 of t is equal to cos 2 pi n t and x2 of t is equal to 2 sin 4 pi n t represent two sinusoids for a positive integer n and t ranging from minus infinity to plus infinity. Which of the following statements about x1 of t and x2 of t are valid? Number 1, x1 of t and x2 of t are orthogonal to each other over t between 0 to 1 by n. That is, for two signals to be orthogonal, for two signals x1 of t and x2 of t to be orthogonal, integral 0 to the period I mentioned 0 to 1 by n x1 of t into x2 of t dt should be 0. So what is x1 of t? x1 of t is cos 2 pi n t. So that is integral 0 to 1 by n cos 2 pi n t times 2 sin 4 pi n t should be 0. So let us see what this is. So cos A 2 sin A cos B is equal to sin of A plus B plus sin of A minus B. So cos 2, therefore 2 sin 4 pi n t times cos 2 pi n t is equal to sin A plus B, which is sin 4 pi n plus 2 pi n is 6 pi n t, 6 pi n t plus A minus B is sin 2 pi n t. Now if you integrate, here there should be a dt. So if you integrate this, you will get integral of 0 to 1 by n sin 6 pi n t plus sin 2 pi n t dt. Integral of sine is cos, so this is cos of minus cos 6 pi n t by 6 pi n minus sine 2 pi n t by 2 pi n limit 0 and 1 by n. Sine is cos. So if I put t is equal to 1 by n, so I get this is minus cos, if I put t is equal to 1 by n, 6 pi by 6 pi n minus cos 2 pi by 2 pi n minus lower limit. If I put cos 0 is 1, minus of minus is plus, plus 1 by 6 pi n plus 1 by 2 pi n. So cos 2 pi is again 1 minus 1 by 2 pi n plus 1 by 2 pi n will get cancelled, minus cos 6 pi is again 1 minus 1 by 6 pi n plus 1 by 6 pi n is again 0. So this totally is 0. So the integral x1 of t, x2 of t from 0 to 1 by n is 0. That means x1 of t and x2 of t are orthogonal in the range t less than 0, greater than 0, less than 1 by n. So the first option is correct. The first option is correct. Let us see what is the second option. Second option is they are orthonormal. Orthonormal means the norm of x1 of t is 1, norm of x2 of t is 1, and they are orthogonal also. The first condition should be satisfied, and the second condition on this, their energy should be 1. That is integral 0 to 1 by n x1 squared dt should be 1. Similarly, integral 0 to 1 by n x2 squared also dt should be 1. Now let us see what is cos 2 pi n, cos square 2 pi n t. So let us first find out what is integral 0 to 1 by n x1 squared of t dt. So this is integral 0 to 1 by n cos square x1 of t is cos 2 pi n t. So cos square theta is 1 plus cos 2 theta by 2. So this is 1 plus cos 4 pi n t by 2. I integrate it from 0 to 1 by n dt. So integral of 1 is t. So if I put the limits, it will be t plus t by 2 plus sine 4 pi n t by 2 into 4 pi n limit 0 to 1 by n. So if I put this will become 1 by 2n. 1 by n if I put 1 by 2n, 0 if I put it becomes 0. Here if I put 1 by n, it is sine 4 pi. Sine 4 pi is 0. Sine 0 is also 0 plus 0. So this is 1 by 2n, which is not equal to 1. It has to be 1 for the norm should to be 1 for it to be orthonormal. So it is not 1. So the option 2 is wrong. x1 of t does not satisfy this condition. So option 2 is wrong. Option 3, x2 of t is a harmonic of x1 of t. The frequency for x1 of t is omega is 2 pi n, and omega by 2 pi is the frequency. F1 is equal to is n, and F2 is 4 pi n by 2 pi, which is 2n. So F1 is n, F1 is n, f2 is 2n, or f2 is a multiple of 2 times f1. It's a multiple of f1, so it is a harmonic. And if this frequency is a multiple of the other frequency, it's a harmonic of once this signal is a harmonic of the other signal. So x2 is a harmonic of x1 of t. So option C is also correct. Option C is also correct. Option D, x1 of t and are non-orthogonal to each other, 0 to 1 by 2n. We have done by 0 to 1 by n. Let us see what happens if we replace 1 by n by 1 by 2n. Then what will happen is, so I am just replacing this integral from 0 to 1 by 2n. So sine 6 pi nt plus sine 2 pi nt. Everything else remains same, only the limits are changing, dt. So instead of t here, instead of t is equal to 1 by n, I'll put 1 by 2n. So it will become cos 3 pi and cos pi. So this will be actually, I'm just for ease, for me not to repeat the whole thing, I'm just replacing, instead of 1 by n, I'll put 1 by 2n. So instead of cos pi, it will come minus cos 3 pi by 6 pi n minus cos pi by 2 pi n plus lower limit is the same, 6 pi n plus 1 by 2 pi n. You know that cos 3 pi is minus 1 and not plus 1, and cos pi is also minus 1. So this becomes plus 1 by 6 pi n, and this becomes plus 1 by 2 pi n. So it is actually effectively, this is 1 by 6 pi n into 2, 1 by 3 pi n plus 1 by 2 pi n into 2, 1 by pi n. So this is actually 1 plus 3 by 3 pi n, or 4 by 3 pi n, which is not 0. If it is not 0, then they are not orthogonal. So they are non-orthogonal, which is also correct. So the option A, C and D are correct. Thank you. God bless you.